class we have seen the potential and everything. So now we are going to talk about what? Electric potential due to a uniformly charged thin spherical shell. Okay, and then we will see electric potential due to dipole. And then we can do the sums. Okay, so I have shared the sums to you. So what is that electric potential? First thing is electric potential due to a dipole. Electric potential at a point due to a dipole. Okay, in this we can discuss it in the two cases, yes or no. So the first case will be what? Electric field. So first what we will do, we will just see with equatorial line. Okay, so what it will be, let us consider a dipole minus q plus q, and where the distance between them is 2a. So the dipole moment will be given by what it is, p, negative to positive charge. So consider a point P along the equatorial line. Okay, so which is at a distance x, you can take it. Okay, what is the distance of the point P from the center of the dipole? It is small r. You need to remember always the distance should be measured from the center of the dipole. Okay, that point is very important. So it is r. So now you can take, since these two are at the same distance, right, x and x, if you consider potential due to potential at point P, it must be equal to what? The sum of potential due to minus q charge and the sum of that is potential due to plus q charge. So what it will be, minus q. What is the potential? Minus kq by what is the distance here? X. Plus due to this positive charge, it is plus kq by x. What is the sum? It is 0. So what you can find out here, it is nothing but what? So electric potential at any point, potential at any point due to a dipole along the equatorial axis is 0. Directly you can write it. Is that clear? Any doubt? Any doubt you can tell me. Next is what? Along the axial line. It's very simple. Along the axial line. So same treatment, minus q plus q, and the distance between them is 2a, we are taking it, and the dipole moment is p in this direction. Now what we have to consider, let us consider minus q is at a, plus q is at b, and we are going to find out the electric potential at a point p on the along the axial line. Okay, so first what it is, ap is distance, right? So what it will be here, this is a, this is also a, and what is the distance from the center of the dipole to the point P? It is r. So AP will be equal to what? R plus A. BP will be equal to R minus A. Correct or no? This is total is R and the distance is A. So R minus A, and OP is, you can let OP equal to R. After that you can just consider that. Okay. So now what is the electric potential at point P? It is equal to sum of the potential due to negative charge and positive charge. So V due to my negative charge is what? Minus KQ by R plus A. Then V due to positive charge is plus KQ by R minus A. Take KQ outside one, when you take this side, okay. So it is 1 upon R minus A minus 1 upon R plus A. Correct or no? Simple mathematics. Okay, now KQ, take the LCM, R minus A into R plus A. So in the numerator R plus A minus of R minus A. So which next step, what you can write? Minus R plus A you can write. Yes or no? So R and R get cancelled. So KQ into 2A divided by R square minus A square. But we know that what is dipole moment? P equal to Q into 2A. Correct? So which we can substitute here. So it will be Kp by R square minus A square, which is nothing but electric potential at a point P along the axial line. Is that clear? Any doubt here? For a short dipole, what you can do? For a short dipole, R is very greater than A. That time we can ignore A. So Kp by R square. Okay, anyhow electric potential along the equatorial line, it is 0. Can I summarize? In this, any doubt you can tell me. Okay, it's same continuation for the electric field. Now what it is? The points you can just write it. So when I compare, yes, any doubt?
Ma'am, in the previous one, ma'am, you showed to be minus if it will keep you out.
2p. Where?
Ma'am, ma'am, shouldn't it be minus KQ? Because
Minus kq. Why? I have
ma'am,
taken kq outside. So 1 plus Ra, it has minus. This one I have written first and then minus 1 by R plus A I have written. Clear? Hmm. Next is what? Due to the general one, you need not learn the derivation. Okay, it will be very simple only, but you just take down the formula. It is more than enough. Okay, so what it is at any point, suppose this is minus q, this is plus q, and this is the dipole moment p. Okay, at any point p which is not along the equatorial line or axial line. So how will you find the electric potential at this point? Again, the distance has to be measured from the center of the dipole. Okay, so this is the r. So how will you do it? If you take the position vector as r1 and r2, then you can easily do this. So what will be the potential at any point? It is nothing but kp cos theta by r square. That's all. Substitute the value of theta along the axial line. What is the theta, ma? Along the axial line, theta is 0. Correct? So Vp will be equal to kp by r square. And along the equatorial line, what is theta? Theta is 90 degree. So cos 90 is what? Cos 90 is 0. That's why it is 0. You can just remember this. Clear? This is also very simple derivation only. Next. Is that clear, ma? So now when you compare electric field and electric potential, okay, electric field, electric potential due to a dipole, if you compare, see, it is electric field along the axial line is what? It is equal to Kp, 2 Kp r by r square minus a square to the power 2, correct? And for short dipole, when r is greater than a, short dipole E will be equal to 2 kp by r cube. Here for the electric potential, what we have got, ma? It is nothing but kp by what we have got it. So it is kp by r square we have got it. R square minus a square for the longer one, the regular one. And for the short dipole, it is kp by r square we have got. Any doubt here? So next is what? Electric field along the equatorial line, if you get it. Along the equatorial line, it will be equal to kp by r square plus a square to the power 3 by 2. Correct? Here, the potential is 0. You can write it. For the shorter dipole, when r is very, very greater than a, it is kp by r cube. Okay? So this just a comparison so that you can recollect what we have learned there. Is that clear? Any doubt here? See, remember, along the equatorial, the comparison is to show that electric field is not 0, okay? But potential can be 0 at that points. Clear? And electric field, that is potential, can be positive or negative. If the theta is 0, then it is, what is that? Kp by r square. But at the same time, if the point is this side along the axial line, then what it will be? It can be minus. So that also you remember. So remember that potential due to a dipole depends on the angle. That is what important, you have to write it. Okay, so what it is? Electric potential, when you take it, the potential due to a dipole. All these are small points that you need to remember. Okay, potential due to a dipole depends on the distance, that we know that. That is position vector. Okay, but it also depends on what? The angle between position vector and the observation point. Okay, so what it is? The dipole moment vector. So here what you have to write? So that it also depends on the angle between, okay, the position vector and the dipole moment. Just now I explained. See what it is, ma. Here, see. This is what I told you, no, for any other point. So this is the potential dipole moment. Here is the point. So what is the angle this position vector makes with the dipole moment vector? That angle it matters. Clear? So the dipole moment, the potential due to a dipole depends on this angle. This angle is between observation, that is a position vector. This is the point P for which we are determining the potential. So between that position vector and the dipole moment, whatever is the angle, that it depends on that. Okay. But single charge when you talk about, but it is about dipole, no. For single charge, ma, it does not depend on the angle. Correct? Single charge, the potential depends only on what? Only on the R, the distance. Wherever you take, it will be same. In whichever angle you take it, it is k cube by R only. Okay. So you should learn, okay, the comparison between the electric potential due to a dipole and a single charge. For a dipole, it depends on the angle. It depends on R as well as what? It depends on the angle between the position vector and the dipole moment. Whereas for the single charge, it does not. Okay. And potential due to a dipole. See, potential due to a dipole is spherically symmetric. Okay. It is cylindrical. It is cylindrically symmetric. Okay. We have learned point charge is spherically symmetric, right? The same way, it is cylindrically symmetric about the axis of the cylinder, that is dipole. About the dipole axis. Okay. So when you rotate about the dipole axis, the potential will not change. So this is about what? When you talk about, this is the dipole. Okay. It is cylindrically symmetric. So when you talk about this, cylindrically symmetric. So when you rotate it along the dipole axis, what will happen, ma? The potential value will not change. The potential on rotating, if you rotate, or on rotating the observation point, that is the point P about the axis. Okay. Here the potential value, potential V will not change. And you know potential due to a spherical, and that is charge is what? Single charges. Potential due to a single charge is spherically symmetric. Correct? Now, what is the difference between potential? You just tell me, you can write this one on your own. Potential due to a dipole, if I take it, what is it, Parina? It is k cube by R square, correct? But due to a single charge, what it is, ma? K cube by R. So it is inversely proportional to R, whereas it is inversely proportional to the square of the distance. So all these points, try to remember when you solve MCQs and numericals. Next. Now we are moving to what? Potential due to a spherical shell we are going to. It's a simple expression. Already we have done it for electric field. No, the same thing we are going to do it for spherical shell. Okay. So potential due to uniformly charged thin spherical shell. Very simple derivation. Okay. It's easy, and you need to compare electric field and this one. So what it is, let us consider a uniformly distributed positive charge. With the positive charge, the distribution is uniform here. Okay, the surface charge density is sigma. Okay, and let us take the charge is Q and the shell radius is capital R, we are taking it. Okay, consider all these things you need to write. Consider a uniformly charged spherical shell of radius with the charge Q. Okay, now what we are going to do, we have to find the potential at point P. Okay, but here as I see, we have done this for electric field, no? So the same thing we are going to do it. How many points we can take, ma? The point can be outside, or the point can be on the surface, the point can be inside. Correct or no? there are three cases, correct? So the point can be outside. So first case will be what? When P is outside. Okay, P is at a distance R, which is greater than capital R. That means outside point, correct? So we are going to discuss in three different cases. So it is nothing but what? So what it will be, ma? So we know that it is a uniformly charged spherical shell. Where the charges reside, you tell me the charges are residing at the outer surface. But the point P is where, ma? The point P is outside. For the point P, okay, this shell, okay, will behave like a point charge, okay, as if the entire charge is concentrated at the center. Is that clear? See, we usually know that in the shell, the charges will reside outside, okay, uniformly distributed. But when I consider the outside point P, the potential when I calculate it, this shell will behave as if the entire charge is concentrated at the center of the mass, that is the center of the sphere. So what it will do, the potential if I calculate for this point which is at a distance r, Vp will be equal to what? It is simply kq by small r, you can write it. Okay. So it's not at all in derivation. We are just learning it how it is. Okay. Next is what? The same thing when the point is on the surface, that is r equal to r. Okay. Here also what will happen? You can find that the potential will be equal to k small q, because I have taken the total charges small q, right? So it will be kq by capital R, and this value is the maximum, right? Okay, this value is maximum because as the small r increases, potential decreases. But this is the maximum radius value you can have, and it will be the maximum value. Okay, ma'am, then what about the point inside the sphere, that is when r is less than r? Now you tell me, ma'am, okay? Inside the sphere, okay, inside the spherical shell, what is the electric field? This is a spherical shell, conducting shell, right? What is the electric field inside this spherical shell? The electric field is zero, right? The electric field is zero. So, wherever you go there, electric field zero means the charge should be zero. Okay. So, here when I talk about this, what will happen? Any charge, suppose electric field is zero if you talk. Suppose you are bringing the charge from the surface to the point P. You are, just imagine that. You are bringing the charge from surface to the point P. Okay. So what it will be, electric field is zero inside. So what is the work done in bringing the charge from surface to this point? It will be equal to zero, yes or no? Because there is no electric field inside. When there is no electric field, no electric force. So work done will be equal to what? Zero. Work done is zero means potential is work done in bringing a unit charge. So work done zero means electric potential will be zero or constant. Here it cannot be zero, right? Sorry for that. Potential difference is zero. I should be very careful. Potential difference is zero. I told you very clearly from the beginning. Electric potential we learn only for definition purpose. Whenever I talk about the problem and the derivations, we are talking about the potential difference. Correct or no? The potential difference. Since the work done in bringing, because we are not bringing the charge from infinity to the point. Yes or no? Lakshmi, we are not bringing the charges from infinity. Here we are moving the charge from where? The surface to the point P. So we have to consider the potential difference. Since work done is zero, work done zero means what is the potential difference? Potential difference is also zero. Potential difference zero means what it is? From the surface to the point P, you are moving it, right? So Vs minus Vp, what it will be, ma? It will be equal to 0. That means Vs is equal to Vp, or Vp minus Vs also you can take. So what it will be? Vs equal to Vp. Potential at the surface must be equal to what? Potential at the point P. Where is the point P? The point P is inside the shell. So the potential must be equal. What is the potential at the surface? We already calculated. So kq by r. So potential inside the shell from the center to the surface, it will be equal and constant. So potential is constant throughout the shell. Correct or no? Till from the center, potential is V is constant. From where? From center to the surface. Is it clear? Any doubt? Till here any doubt you can tell me. So now when I write together, what happens? So outside when I see, potential is kq by small r, correct? That is r is greater than r. R equal to r on the surface, v equal to kq by small capital R. R is less than r, then also that is inside the surface, what we got now? It is kq by capital R only. So if I draw the graph between these two things, what it will be? So this is V, this is small r. When r equal to r, that is the maximum value, and from the center of the spherical shell to this point, it is equal to kq by r maximum, correct? Then what happens? It is inversely proportional. What happened? So when I draw the graph between V and small r equal to capital R, what is the value? It is the maximum, that is kq by r. The same thing holds good from the center to the surface. But beyond that, what happens? It is inversely proportional to the small r as the distances increases. So what will happen to the potential? Decreases. So this is the graph for that. Now I will compare electric field and electric this one. Okay, what it will be? We have just seen, just to recollect. Okay, so what is electric field? When I talk about electric field due to a shell, okay, and the potential, you know that outside, that is r is greater than r. What is the value of E? It is kq by r square, correct? But here what is V? It is kq by r. And when r equal to capital R, E will be equal to kq by capital R square. V will be equal to kq by capital R, correct? Where capital R is nothing but what? The radius of the sphere. When r is less than r, E will be 0, but V is what? V is constant. Okay, from center to this one, V value is constant. So when I draw the graph, you need to remember that for this E and R, okay, what it will be? The graph starts from only this point, correct? So this is the maximum and it is minimum. So dotted line we usually represent, and here it is what? 0. Correct or no? Electric field will be 0 till capital R. After that only electric field comes. So this point is the maximum electric field, and here it is inversely proportional to R. So you need to learn the difference. That's when you can remember during the exam. These are all simple, basic level physics. Clear or no? Any doubt you can tell me. So the next is what? We can start the numericals for the class. And did I miss anything? Let me see. Okay. So I told you that one, right? So now that also I will teach you electric potential at any point due to dipole. See, this won't be asked in CBSE, but you need to know how the logic behind it. So what it is, a quick, okay, I will do it very quick. So this is the electric the dipole with the dipole moment P, and the point P is here. So now I am going to find this distance, that is R1 vector from minus Q, and all the distances we have to measure it from the center. So the point P is at what? R from the center. And what is this? Minus plus Q. It is at what? R2. Okay. Now listen carefully. It is little mathematics. Okay. Now when you have two lines, okay, from the same origin, okay, how will you make these two lines equal? If you have to make these two lines, okay, the distances equal, then what you have to do? Simply I will teach you. That is, you have to draw a perpendicular. Okay. So when you draw the perpendicular line, then what will happen? This OA and OB will be equal. But the second line is little bit more, right? So this will be what? This, if you take it, this is the extra length. Is that clear? Any doubt? So this is how you can make the distance equal. So the same logic I have to use it here also. Okay. So clearly it is seen that, okay, from the diagram, it is clearly seen this R1 is greater than R2. Correct or no? R1 is greater than R2. R is greater than R2. Correct? R1 is greater than R. R is greater than R2. Correct or no? So now I have to find out the extra distance, and doing some mathematical calculation, I need to find it out. For that, what I will do? First, I will extend this line because it is smaller, right? So from this, I have to draw the perpendicular line. So what will happen? I will make both of them equal. Okay? When I draw this R1 a perpendicular, so that this R position vector along with this extension will be equal to ON. Okay, so now what I have done, NP is nothing but what now? ON plus OP, right? So with the extension, I can make what? R1 equal to the magnitude of R1 is equal to magnitude of R. Okay, so now what I can do it here, this is P, A, B you take it. Okay, now PA can be written as what? PA can be written as NP because I have made them equal, right, by drawing a perpendicular thing. So PA can be written as what? It is equal to PO plus ON. What is PO ma? PO is, PA is R1. PO is R. But do I know this distance? I don't know this distance. What I can do? Listen carefully. This is A, I know. This is also A. Correct? Because dipole of length 2A we have taken. Any doubt till here? So we have taken minus Q and plus Q. Okay. So the distance between them is what? It is 2A of length. And we consider a point P which is at a distance R from the center. And from minus Q, where is the point? Diya, R1. From plus Q, what is the position vector? R2. So what we are going to do? We have to make this R1 vector equal to this R. So in terms of R, we need it, right? Because all the distances are measured from the center. So everything we need in terms of R. So I have extended this central line so that now PA will be equal to what? NP. So PO plus ON, correct? So it is PO is R vector, I know. ON is I don't know. So what I have considered here? I have considered the A, and here let us consider the theta. We know that just now I told you the theta is the angle between position vector. Theta is angle between what? Position vector and dipole moment, correct? So theta we consider. So if this is theta, you tell me ma, this is a, what is that? This is perpendicular line. So in triangle AON, so right angle triangle, right? I need what? ON, adjacent side. So cos theta will be equal to ON by OA. What is OA ma? It is nothing but what? The half length of the dipole. So which is A cos theta is ON. So what I can write it here? This one ON, instead of that I can write A cos theta. Is that clear? Next is what? I have to do the same thing with R2 also. But R2 is lesser than R, so I will draw a perpendicular here because I need everything in terms of R. So R2 can be written as what? Ma'am, it can be, if I take M is the perpendicular, then you will say that ma'am, OP minus OM I can write. Correct? OP minus OM. So what is OP ma'am? It is R vector. What is OM? Again it is what? In triangle OMB, it is the cos theta, right? Cos theta is opposite, adjacent by hypotenuse OB. So OB is again A cos theta. So it is R minus A cos theta. Clear? So this is R2 vector. So now when I take VP, okay, so the potential at the point P is due to plus Q plus potential due to minus Q. So what is due to plus Q? It is nothing but KQ by what is the distance ma? The distance of this vector is R2, right? Instead of R2, I can write it as R minus A cos theta minus KQ because potential of negative charge is minus only. Minus R plus A cos theta. So when you do the mathematics, that is final this one, R square minus A square cos square theta. Here what it will happen? KQ into 2A cos theta. Do the math by yourself. Okay. So what it will be here? It is VP will be equal to Q into 2A is what? KP cos theta by R square minus A square cos square theta. When R is very, very greater than A, VP will be equal to what? KP cos theta by R square. Otherwise, you have to consider this. Clear? So that's why I don't want to leave that now. First sum. Everything is direct based. There is formula based sums only ma. Okay, the work done in moving a charge of 3 coulomb from point A. So this is the point A. Here, whenever you calculate potential, you need to have the points very clear. A to B we are moving. Okay. We are moving from A to B. So potential difference when you take VB minus final minus initial, VB minus VA I have taken, which is at a potential of, okay. So VA is given as what? Minus 2 volt. VB they have not given, we have to find it. Okay, to another point, work done they have given. Work done is what? 18 joules and charge is what? 3 coulomb. So VB minus VA is W by Q. So VB as it is I can take it. VA is what? Minus 12 volt. So minus of minus 2 and what it is? 18 by 3. So VB plus 2 will be equal to 6. VB is 4 volt. Direct substitution, yes or no? Is there any difficulty in this? No. It's a simple sum. Okay, next is what? I have shared the PDF, so you just take down the example 1, 2 like that only. Okay, and just write the date, it will be easy for you. Find the electric potential at the surface of the atomic nucleus given the charge on proton. Very simple, right? Atomic nucleus. Atomic nucleus, what is the charge of that? They have given clearly, right? Nucleus, the atomic number given. So that means number of protons. Atomic number represents what? Number of protons. Okay. So here what it is equal to Z is 50 they have given. So charge of nucleus is what? Charge of nucleus is Z into E. Correct? Atomic number into the fundamental charge. So how much? 50 into 1.6 into 10 to the power minus 19 coulomb. This is the charge given. And what is the radius of the nucleus they have given? It is 9 into 10 to the power minus 13 centimeter, which is 9 into 10 to the power minus 15 meter. Correct? Any doubt till here? Then what is, it's very simple, right? On the surface, just now we calculated, right? The potential at any point due to the surface of the spherical shell, what it will be, it is nothing but KQ by R. Correct? So it is nothing but 50 into K is 9 into 10 to the power 9. 50 into 1.6 into 10 to the power minus 19 divided by 9 into 10 to the power minus 15. 9 cancels. Okay, 50 into 16, right? So it will be equal to 80. 16 5 sir, it is 80. Okay, so it is 10 power 9 minus 19. How much? Minus 10. Minus 10 cancels. It is plus 5. So 8 into 10 to the power 6 volts. Just check whether you are getting the same answer. Okay. Very simple substitution. Because most of in the nucleus, you know that, right? That, okay. See here, you must remember, none of you bother to ask me question, because why did you use KQ by small r, ma'am, instead of KQ by r? Because the nuclear radius is what? 10 power minus 15 meter Fermi. Nuclear radius is of the order Fermi. Fermi means 10 power minus 15. Since this point is outside, the given value is what? 9 into 10 to the power minus 13, which is more than this Fermi, right? 10 power 100 times more than. So that's why this point is what? R is greater than capital R. So the point is an outside point. For an outside point, the spherical shell behaves like a point charge. That concept it should come to your mind. Is that clear, all of you? This is an outside point and it will behave like a point charge. Next is what? The question 3. It's also very simple. Steps are important. Okay, you can do it with calculate the potential at a point P due to the charge. Okay, this is the charge which is of value 4 into 10 to the power minus 7 coulomb located at 9 centimeter away. So we know that very simple, right? Vp is equal to ma'am KQ by R. So it is 9 into 10 to the power 9. Q value is 4 into 10 to the power minus 7. 9 centimeter. So this cancels, ma'am. 4 into 10 to the power. This is minus 5 means it is 4 volt. Correct? Any doubt here? Potential is given now. So now you have to bring what? Work done in bringing a charge of, you have to place a charge of Q into Q, that value is 2 into 10 to the power minus 9. Correct? Potential is given. Charge value is given. They ask you for work done. What is that? Potential at any point is given by work done in bringing a unit positive charge from infinity to that point. Correct? So Vp is W by Q. W will be equal to Q into Vp. Correct or no? So Q is 10 power 2 into 10 to the power minus 9. This is 4 into 10 to the power 4. My handwriting is, it is 4. Okay, it is 4 means here 8 into 10 to the power minus 5 joule. Is it clear? Now what did they ask? The answer depends on the path along which it is traveling. You tell me whether it depends. Conservative force, right? Being electrostatic force is a conservative force. Electrostatic force is conservative force. So work done does not depend on what? Work done does not depend on path taken. So the answer will not change even if you change the path. Correct? Next. Is that clear? Any doubt till here? Next is what? A metal wire is bent in a circle of radius 10 centimeter. Okay. So what they have given? Metal wire. Take a metal wire. Okay. This is bent in the form of circular, in the form of circle with radius r is what? R equal to 10 centimeter, that is 10 power minus 2 meter. So the charge is given and the charge is distributed uniformly all over the surface. That is Q value is 200 microcoulomb. We need to find out the electric potential at its center. Whenever circular ring comes, you know that we need to go for what? Integration technique only. Why? Here we have to consider the point. This is a elementary charge. Correct? We will consider a small element dl in which a small charge dq is there. Okay? Large number of elementary charge. If you just add all the dq's, you will get the total charge. Correct? So, the charge is what? In the element, small element dl, the number of charges is dq charges. Correct? So, what will be the potential? So, small potential. Potential due to small element. Potential due to small charge dq is what, ma? It is dv equal to k into dq by what is the distance? Of course, it is radius r. Correct? At the center. So now what it will be to find due to all the elements. Okay. What we have to go, what we have to do? Go for integration. From integration where to where, ma? Because we have taken the integration along the dq. From 0 charge to q charge we have to do it. Correct? So what is the integration? dv. What is integration of dx? It is x. Integration of dv will be equal to v. Integration of dq is dq only. So this is potential at that point due to center. Now what it is? K by r, which are constant. Radius is constant, right? For a given sphere. So it is dq only. So integration of dq is q. Always upper limit minus lower limit. So k by r, q minus 0, which is kq by r. You may ask directly, I could have substituted. No. This is the proper method of doing. Okay. So now what is the value, ma? 9 into 10 to the power 9. Q value is what? Is it given? 200 microcoulomb, I believe. 200 microcoulomb divided by R value is 10 centimeter. That is, sorry, just let me see. 10 centimeter. 10 power minus 2 meter. 10 into 10 power minus 2. So what will happen? This cancels. Okay. So 18 into 10 to the power 10 minus 4 is 6 and 4. Okay. So 1 minute. Did I do it properly here? It is 10 power minus 2, right? So it will be minus 4. So it will be 5. Correct. But here 90 into this one is there. 180 into 10 to the power 5. So 18 into 10 power 6 volt. Just check the calculation once by yourself. Any doubt till here? Everything is direct. substitution only. So far we have not entered into any complex numerical. If any doubt, you can tell me. So Iraj, are you focusing or this is fourth? Electric field intensity at point P due to a point charge Q. Okay. So decode it. So first is a charge Q is there and at a point B. Okay. The electric field intensity at point B due to a point charge kept at A. That much we have done. Okay. Is 24. So electric field is what? It is 24 Newton per Coulomb. And electric potential at the point B is what? It is 12 Joule per Coulomb. Calculate the distance AB and the magnitude of it. Very simple, right? Just now we have learned the relation between these two things. What is electric field, ma? KQ by, what is the distance here? It is R square, correct? And what is V? V is simply KQ by R, ma. Now divide V by E, ma. V by E will be equal to KQ by R into R square by KQ, correct? So this cancels, 1R cancels, you will get R. So simply by dividing V by B, V by E you will get R, correct? So 12 by 24, it is 0.5 meter. Is it clear? Any difficulty? Next, they also ask you to find the charge value. V equal to KQ by R. So unit charge means VR by K. So what is V? V is 12 and R is 0.5 divided by K value is 9 into 10 to the power 9. So this is 4 by 3. So 4 into 0.5 is 2 by 3 into 10 to the power minus 9 Coulomb. This much is in. Clear? Any doubt? Next sum you can try on your own because it's a very simple sum. I am doing it along, just do it along. Now, to what potential we must charge an insulated sphere of radius 14 centimeter so that the surface charge density is equal to surface charge density Q by A is equal to what? It is equal to 1 micro coulomb per meter square, that is 10 power minus 6 coulomb per meter square. Okay, they are asking you to find out the potential, we have to find it, that is KQ by R. Correct? Because the radius already they have given, the radius of the sphere is 14 centimeter, that is 14 into 10 to the power minus 2 meter. So potential we need to find, but before that what we need? We need charge, correct? So either what you can write, it is equal to KQ by R. Instead of Q, what you can write it, ma'am, it is Q equal to sigma into A, ma'am. So you can write it as what? K into sigma A by R. What is A, ma? Spherical shell, right? So spherical or sphere, insulated sphere they have given, not shell. Okay, insulated sphere only they have given. So yeah, surface charge density since they have given. So sigma into, what is the surface area, ma? Surface area is 4 pi R square because R is the radius. So divided by R. Now what can be cancelled, you tell me? K into sigma into 4 pi R. What is the value of K? 9 into 10 to the power 9. Sigma is what? 10 power minus 6. 4 into 22 by 7 into 14. So this 2. So how much it is? 9 8s are 72 into 22 into 10 to the power 3. I hope I have calculated all the values. Correct? One 5 8 4. Okay. Here I think somewhere 14 into 10 to the power minus 2. Correct? So it will be clear, all of you? Any doubt? Diya, is it clear, ma? Next you can do on your own because it's a very simple sum. Okay, direct substitution. A charge of 24 microcoulomb is given to a hollow metallic sphere. So just now we have seen, right, on the surface, outside the point and inside. So at the surface of the sphere, if you want, it is KQ by capital R. where r is the radius, right? R is given as 0.2 meter and charge is given as 24 microcoulomb, that is 24 into 10 to the power minus 6. So it is 9 into 10 to the power 9, 24 into 10 to the power minus 6 divided by 2 into 10 to the power minus 1. 0.2 I have written is 2 into 10 to the power minus 1. So this is 12. 12 into 9 is nothing but what? 108 into 10 to the power 4. So 1.08 into 10 to the power 6. At a distance r, at a distance 0.1 centimeter, 0.1 centimeter is very less than capital R, which is 0.2 meter. So inside the sphere, inside the shell, the potential is constant and V value is 1.08 into 10 to the power 6. Now you write, all of you. Next question. This question also we have done it in the class for the electric field. Now we will do it for potential. Okay. So you can use the steps for CBSE, but when it comes to MCQs, competitive exam, I will give you the, after completing the capacitance, I will list out you everything. That time you can just use that formula. Okay. So 27 drops. So 27 drops of single charge combined to form what? One big drop. Correct? But what we need to remember, the volume remains same, correct? Volume will be same. Volume remains same because when you combine this many drops, when you make a one big drop, the volume is going to be same. That means we have to first find out volume of small drop, correct? Volume of one small drop. How much it will be? It is spherical in shape, drops are. So 4 by 3 pi small r cube I will take. Okay. So 27 drops. What is the volume? Ma'am, it will be equal to 4 by 27 into 4 by 3. Don't cancel anything. Okay, don't do any calculation. Just write 27 into 4 by 3 pi r cube. Correct? So volume of big drop is what? Ma'am, if I take the big drop radius as capital R and the small drop radius is small r. Okay, so volume of the big drop is 4 by 3 pi r cube. Correct? So this must be equal to this. Correct or no? 1 must be equal to 2. So 27 into 4 by 3 pi r cube must be equal to what? 4 by 3 pi capital R cube. Now 4 by 3 pi will cancel. So 27 r cube will be equal to capital R cube. Okay, so what it will be? Capital small r, we know that means capital R we need to find it. So it will be, if you take the cube root, what it will be? It is equal to 3r. Correct? Yes or no? Any doubt?
Ma'am, I didn't understand why volume of what?
Just imagine, Kanna. See, volume, you just take small balls, okay? Any small pith balls or any balls you take it and you just combine it to form a big ball. You fill it in the ball, okay? Take one big ball, okay? And you just fill the balls with the smaller balls. Fill the ball with the smaller ball. What you will get it? The volume remains same with the number of balls if you count, right?
Yeah.
Same thing. Okay.
Yes.
Or when you imagine, maybe the bigger ball, it is of fixed volume, correct? Because you are already taking a ball which is made, okay? So that time it will be. But here we are just one by one. You just imagine the water droplets are getting added. That's why the volume remains same, okay?
Yes, ma'am.
So R equal to 3R. Now, what is the charge on one drop? Charge on one drop is, let us take small q. 27 drops, what it will be? It is equal to 27 q. Correct? So this is nothing but what? Charge on big drop. Correct? Charge on big drop, that is capital Q, is 27 q. Now, potential of big drop. Okay, what it will be? Ma'am, usually it is given by K Q by R, right? Where R is the radius. So it is 27 in terms of small drops. If you write K into capital Q is what, ma? 27Q. Capital R is what? 3R. Correct? So now what you are getting? It is 9 times. kq by r. Now what is small kq by r given? The potential of small drop. Read the question. It is given already. It is equal to 220 volt. So that is nothing but kq by r is 220 volt. It is given. So V will be equal to 9 times 220, which is nothing but 1980 volt. Is it clear, all of you? Any doubt?